Thank you very much, and welcome, ladies and gentlemen, and thank you for the opportunity being here. And I want to show you something about fire-resistant glazing, and especially today I want to point out the topic about the application of fire-resistant glazing in facades. So first, only a very short introduction of our company. Schott is a very old German company founded more than 130 years ago, and our goal is specialty glass and for very different applications. And we have here you can see the figures. It's a global active company. And I have to admit, unfortunately, the sales, it is unfortunately not only with fire-rated glass. But this is our topic today, and the question is how to combine fire protection and other functionalities in architectural solutions. And what I have heard, there are many architects here as well, and I guess the architect doesn't want to have only a fire-rated glass only for itself. I think the fire-rated glass shall fulfill also other requirements like UV value, like design requirements and so on, and by the side it should also fulfill the fire rating and the security requirement. So there are a lot of different areas in a building where we need to have fire rated glass. The most prominent area, as you all know, is the fire rating or the protection of escape routes. And of course, if you want to have glass in the escape route, it shall be a fire-rated glass. But also, as you can see here, the partitions and the doors and also roof glazings, these are all applications for fire-rated glass. And our topic today is especially the application for facades. And this is a very interesting and a very, let's say, up-to-date topic, because all of you, I'm sure you have still in your mind the crucial fire in London, the Grenfell Tower, where more than 100 people died. And it was not because the glass failed, but it was because the facade system failed, so that the fire could spread very, very quickly from one floor to another. And a comparable fire there was in Dubai also, I think it was last year. Fortunately, nobody died, but it was in principle the same, that the fire spread very quickly from one floor to another. And the question is how to avoid and how can we pretend such a behavior of the fire. So let me give you first an overview of the classification, especially of the European classification of fire-rated glass. So we distinguish between three different classifications. This is the criteria E for integrity, and the requirement for E-glazing is only, like the name is showing, only integrity. E-glazing, there is no measurement of the heat radiation which goes through the glazing. And the other most prominent in Europe, the other most prominent classification is the EI classification. This is integrity and insulation. And here for EI, there is the temperature measured on the unexposed surface of the system, also of the glass. So the temperature is measured, and in difference to EI, there is some classification in between. It's called EW, but in difference to EI, the temperature is not measured on the surface, but the radiation is measured in a certain distance, in particular in 1 meter distance from the specimen. So it's not the temperature, it's the energy which is measured. And a couple of years ago, this new naming of the different classification was introduced in Germany and launched, not in Germany, in Europe, was launched and issued in Europe. And now in Europe we have common naming of the different classifications. And here you can see the meaning of these letters which we are using for E, EI, EW. And the system is actually very easy. So E is the French expression for integrity. Please do not force me to pronounce the French. I have no clue how the pronunciation is, but the meaning is integrity, and therefore the letter E. And for insulation, we are using the letter E, and EI therefore is only a combination of E and I, so that we have integrity plus insulation. The same is with the radiation. The radiation has the letter W, and so it is only the combination E and EW, which means integrity and reduction of the radiation. So this is in principle the system of the European classification and the naming and the wording of the European classification. So, but now coming, let me come to our main topic today, facades and glazing in facades. And we distinguish two different situations in the facade. The one situation is to prevent against horizontal spread of fire. That means we have, for example, a building with such a shape, and the target is and the goal is to prevent, if there is in this area of the building a fire, that the fire doesn't spread round the corner or across the corner to the other area of the building. And therefore, there are in the most building codes in Europe, there are an area of the facade defined beginning from the corner to the facade, and it depends on the country and the building code. It can be from 3 meter to 7 meter distance from the corner to both sides, so that if we have a fire here, that the fire cannot spread because of this fire protection barrier to the other part of the building. And similar is the case if we have a skylight in front of an upgoing facade, like you can see here. So it's in principle the same. We have a fire here in this area, and the fire, to prevent that the fire spread over the skylight to the above orientated windows, we need this area as fire protection. This is the principal system, what we know in the most building codes in Europe to prevent the horizontal spread of fire. In the other case, and this is more prominent than the horizontal spread of fire, is to prevent and to avoid the vertical spread of fire. This is exactly the case what you have seen in the pictures of this crucial fire in London or in Dubai. So what can we do, how to prevent that the fire jumps from one floor to another? And therefore, in the most building codes, there is a barrier defined here as a limitation or a barrier from floor to floor. And the height of this barrier, this fire protection barrier, is also different from country to country. I have learned that in Brazil, the level or the height of this barrier is 1.2 meter. It's very similar also in other countries. We have sometimes 1.1, 1 meter, or even 90 centimeter. And it depends also on the height of the building. So if we have a high-rise building, this barrier is higher than a lower building. But in principle, it's very, very important for all of such buildings to have such a fire barrier to prevent that the fire can spread from one floor to another. So how to solve it in case that you want to use glass, and as much glass as possible, a fully glazed facade, which we of course appreciate, but how to fulfill it to have this barrier included in the facade. Also, this barrier, how can you include it in your facade system? So that you do not have a difference in the appearance of the facade from the other non-fire rated areas of the facade. And this is not very easy, and here we come to the different glass types and what is the most reasonable glass type to fulfill this requirement. And here you can see the two options of glazings, the E-glazing or the EI glazing. And the E-glazing has big advantage because it's very thin. And the EI glazing, we have different interlayers, what you can see here, and the thickness is more than E-glazing. To give you only an example so that you can imagine the difference between the thickness of E and EI, if we consider a requirement for 2 hours, 120 minutes, the thickness of an E-glazing, of an E-glass is 6 mm, 6 millimeter. Compared to an EI glass for 120 minutes, the thickness is 52 millimeter, only the single glass. And so you can imagine it is very, very difficult to combine such a system, such a big system in a standard facade system. And therefore, from the technical side and from the combination side, an E-glazing is much easier to handle. And we have to consider that in such cases that we have to prevent the spread of fire from one part to another, the fire goes in every case outside of the room, outside of the building. And then after a while, after a certain distance, the fire wants to come again in the building. And this passage and this distance is outside. Therefore, the atmosphere absorbs a lot of the energy of the fire. And this is the reason, and I will show it you later on in another slide, this is the reason why in the building codes or in the test methods of the European standard, this case and the temperature curve is different if we are talking about facade systems or internal partitions. And this is a test setup of a facade test in, this was at a test institute in Germany. And there is a special standard how to test facade, curtain wall facade systems. And here, for example, the curtain wall system is that the facade is mounted in the front of the slab. So therefore, the testing has to consider not only that the glass doesn't go through the glazing, but the test setup has also to consider that the glass and the flames do not pass on the mountaining, through the mountaining to the slab. And that's the reason why in this test setup, it's a 5-meter furnace, and this test setup displays this situation. That means on top, the facade system goes in front of the furnace up more than half a meter. And so we can simulate this system and this situation. In difference, we have also the situation that we do not have always a curtain wall. Sometimes we have external walls, like a window, or like a couple of windows combined in the wall, in an external wall. And the test for this external wall is different to a curtain wall, because the external wall is installed 4 sides on the wall, on the brick wall. So here you can see this is the installation and the mountaining of an external wall. And the external wall is connected on 4 sides to the surrounding wall. This makes a huge difference in the test method and in the installation. But what I mentioned before, in summary, for both systems, we have to test, or we have to distinguish the temperature curve if the test is from inside conducted or from outside conducted. And in any case, the test has to be done from both sides. So we have to carry out in Europe 2 tests. The first test is from inside, and from inside the test has to be done according to the standard temperature curve. And here you can see the standard temperature curve rises permanently up. So we have, after 120 minutes, we have a temperature more than 1,000 degrees. And this is the case in the test method if the fire is here inside. But the second test, to simulate when the fire is outside and wants to spread in the next floor, then we do not need, because of the absorption of the energy by the atmosphere, we do not need to carry out the test according to this standard temperature curve. And for this test, an external temperature curve is defined, and you can see it here. Sorry, you cannot see the temperature, but here the temperature stops at 600 degrees, and it keeps the 600 degrees up to 2 hours. And similar it is for skylights. Also for skylights we have a little bit of differentiation to the facade systems. And in skylights we have to test only from one side, only from internal. I think make sense, or it doesn't make sense to test from outside because the fire will not go inside through a skylight. So we have only to test from inside. And I know from many discussions in Europe, the firefighters and the fire consultant, they think that the glazing will withstand the fire and also will not fall down for a certain time, for 30, 60 or 90 minutes or whatever. But in any case, independently, if we use an E-glazing or an EI glazing, what you can see here, in any case, the upper glass will fall down. This we cannot avoid, and this is also not the target of the fire-resistant glazing, because the target is to prevent the spread of fire to the next floor. And therefore, the firefighters and all the participants at such a building, they must be aware that in case of fire, the glass will fall down from the skylight. I was explained, sorry, I'm not a firefighter, but I was explained from European firefighters that it is not mandatory and it is not a big deal that the glass falls down, because in case of fire and when the glass falls down, there is anyway nobody under the roof and inside of this skylight. So sorry, I have mixed the slides, because here I wanted to show you, especially for this case of the fire protection barrier from one floor to another, a very tricky solution. Because what solutions do you have to fulfill this requirement, this barrier? So the easiest way and the most important way would be, and we would be happy, but it's nonsense, to have the whole facade with fire-rated glass. It would make us happy, but it makes no sense. And the other way is you have only parts of the facade and you include in the facade a fire-rated glass. This is also very, very difficult, because you have seen in the slide before that the fire-rated glass in the composition can have a different thickness and different appearance than the rest of the facade. And also the system does not fit, and there's no test evidence that the system of the facade will fulfill the fire rating. So therefore we have, based on a requirement from a project in France, I will show it to you later on, there was the idea to move this barrier on top on the ceiling, so that the barrier is not here mounted or installed at the floor and at the bottom. The idea was to move up the glass to the ceiling and to install it above on the ceiling, like where we have a lot of experience, like smoke screens, which are also installed on the ceiling. And we have carried out a fire test, you can see it here. And the glass was installed on 3 sides. And this test was for 60 minutes, but it would stand also for a longer time. But the requirement for this French project was 60 minutes. And, sorry, and I show you afterwards how it looks like in this specific project. So to summarize this facade system, or to summarize the application of the proper glass, it's from our point of view, the e-glazing is the most sufficient glass for facade because of the absorption of the energy of the atmosphere, and therefore it's not as expensive and not as difficult to include an e-glass in the facade and in the complete system. But I have to point out very seriously that an e-glazing in an escape floor, in a very narrow escape floor, an e-glazing is not the right glazing. For escape floors in internal areas, as you can see here, if you have a glazing there, an EI glazing is mandatory because of the heat radiation, and you cannot pass an e-glazing very close to an e-glazing. You cannot pass an e-glazing during a fire, and therefore for such escape routes, it's really mandatory to use an EI glass. This is not the proper application for an e-glass. So, and now I want to show you some applications where we have done e-glazings in facades, to give you an example how it worked in the practice, and especially this French system I want to show you a little bit more in detail. Here you can see this building, and like you have seen in the slides before, these areas we need to fulfill this fire protective barrier, and it was also 1.2 meter. And the system, what you have seen in this photo, what we have tested is like here, the glass, the e-glazing was installed on the slab here on the ceiling, and the facade, the outer facade here, was not interrupted by another fire-rated glass. And in summary of, or in total, the thickness of the slab was 40 centimeter, and so the glazing, the e-glazing was 85 centimeter, and in total we had this barrier of 1.2 meters. And in case of fire, if the fire is inside, if we have the barrier on the floor or on the ceiling, we have anyway the barrier, so the effect is in any case the same, independently where the barrier is mounted. And this is a photo through the facade, and you can see here there is this e-glazing installed, and it's almost invisible. So you can see here it's not disturbing, and also to install the heating on the floor, no problem at all. And so it's a very smart and very tricky solution. Another solution or another project is this project in Germany. And here we had a typical skylight in front of going up facade. And it's very typical because you can see here the windows above the glazing, and therefore the target was to prevent, in case of fire inside of this skylight, to prevent that the fire spread through the glazing to the above windows. And therefore, here in this area, we had fire-rated glass. The classification here was E30. And this is the view from internal. So you can see here very, very good that it is necessary to protect the above windows against spread of fire. And especially for e-glazing, it was also a comment of a firefighter in Germany. He said, I prefer for skylights more an e-glazing instead of an EI glazing. Because in case of fire, if we have a fire here, the e-glazing above, if here would be an e-glazing, the e-glazing would insulate because of the insulation function, and so the temperature will increase here more compared to an e-glazing where the temperature and the radiation can go through the glazing. That's not my idea, I have to admit it was the definition of a firefighter. So typical facade applications you can see here. This is also a building where the complete facade was done with fire-rated glass. It was a point-fixed fire-rated glass, and you can see it's a very transparent building, and therefore you have only the slab as a fire barrier, and this was not enough, and therefore the decision was here to have the complete facade in fire-rated glass. This project in France, in Paris, is also very typical because you can see here the high-rise towers, and the connection between the towers is also needed to have fire-rated glass to avoid that the fire can spread from one part of the tower to another. It's also a very typical application. Also, this smaller building, but it's also very typical. This is the staircase, and it has also to be protected in between of these two parts of the building. And yeah, this is the location of the construction authority in Munich. And they have here also the same application as fire-rated glass. And a very nice, a very fancy building. It's called, because of the shape, it's called the Wall. The Whale in Budapest. And here there was the challenge because the fire-resisted requirement was in the connection from the facade to the roof and to the skylight. And therefore, the basis for this project was also a fire test which has to be carried out. And in addition, at this fire test, it was also requested to test the different shapes. So we have here a lot of triangles, and we had to prove that also the shape as a triangle fulfills the requirement. Here we have a little bit a different situation, not an external facade, but also very often huge atrium. And this hotel, Hilton Hotel in Frankfurt, is a very good example for such a huge atrium. You can see here, here you are looking inside from the atrium to the surrounding parts of the building. And here you can see this floors and this protection of the floor and the close rooms, hotel rooms nearby. And here you can see an e-glazing, and also the argumentation for the e-glazing in this case was if there's a fire inside of the atrium, the temperature on top here is not as high as in this standard temperature curve, and therefore it is sufficient to have an e-glazing even if it is an internal application. Back to a typical external facade, you can see here, and this is a project we have done this year, also in France. We have a typical shape of building corner, but the wish of the architect was to have bended glass within the corner of the building. And therefore, because all these areas had to be fire rated, including the bended glass, and therefore the requirement was to test a bended e-glass as a double glaze unit within this facade system. And therefore, a test was carried out at Edificações in France. And you can see here, it is a one-by-one test, so it's exactly the size and the system which is installed later on in the facade, so that we have the insurance and the safety that the system works and was originally tested. Again, an atrium situation here, this building in Singapore. This single windows inside of the atrium was also requested for it was E120, and it was also sufficient to use E because of the dimension of the atrium and the exception that the temperature will not rise so high like the standard temperature curve. Also a system and project in Germany, the same situation, an atrium and the surrounding internal facades are E60, and also the same system and the same argumentation like before. Here I want to point out the roof glazing here above had no requirement. This is normal glazing, no fire-rated glass. So, and more or less at the end, one of the most fancy from my side, from my point of view, this project in Berlin, and this skylight completely was or is fire rated, an E60 requirement. And the same if there's a fire here inside, that the facades, the surrounding facades will be protected against fire. And you can see it's a very complicated system, very complicated construction, and also the glass. We have a lot of different shapes, and it's a very, very fancy system. So, thank you very much, and I hope I could give you some impressions what we are doing more or less around the world, and what we are thinking what is the most reasonable application for E and EI glazing. Thank you very much.